The purpose of this little video is to show you one of the projects that I was doing over the last couple of months. So I'm a photographer, I'm also a programmer, and I'm also a hardware engineer. So I wanted a project that would kind of meld everything together. So what I decided to do is to try to do a remote sensor type of project where something would occur, trigger my camera, and take the photograph. My daughter bought me at my birthday last year a Raspberry Pi. And, that is a small little computer that can run Linux. It's an ARM processor. I'm not going to get too geeky on you, but that thing is sweet. And since then I bought two other Raspberry Pis and I've got it cobbled together on a breadboard. And I wrote a program in Java that is an intercommunication protocol where I can send it a command and it will execute a program. So one of the programs that I wrote is a monitor program that accepts text input, parses it, and sends it to the other modules for further processing. So in order to get the camera to work, I wrote one module that communicates with a sensor. So what kind of sensor will allow me to trigger the camera? Well, there's a lot of sensors. I could do audio, I could do ultrasound, I could do a video, I could do laser. Well, of all of those, laser one sounded the most interesting. So I did a lot of research and I found something called a LiDAR 2, and it's from Light Source Industries or something like that. It's a great sensor. Pretty pricey, it's very expensive, but what it does is it lets me range find out to around 40 meters, which is 120 feet. Now I've tested it to 24 feet and it works like a champ. So it talks on a protocol called I2C, and I cobbled together an I2C module in Java that then talks to Pi4J, which is a module written by somebody else that actually talks to the Raspberry Pi. So I fought this for a little while, but basically got it all working. So let me discuss a little bit about what I've done and all the different parts of the puzzle, and I think and maybe a little bit of a demo, and this should work out pretty good. This is my breadboard that I use to have, to play around with my Pis, and I have 1, 2, 3 Pis connected together via LAN. I also have power from just some simple USB chargers going into the tops of these boards. Pi Server 1 is the one that I've been playing with as far as the sensors are concerned, and that is where my laser sensor is mounted. I've tried playing around with ultrasound, and Pi Server 2 has that information, and Pi Server 3 I use for printed circuit schematics and layout. That's really neat, but we won't talk about that one today. This is the LiDAR 2 sensor, which I taped to the back of a USB card reader and then taped that to the wall. Oh, that's where my card reader went. I was wondering where it went. Okay, anyways, sometimes I have old timers and forget what I do with things. But that's basically firing across my shop, which is 24 feet wide. So whenever I cross that beam, it triggers the code, which then will fire off the camera. Now I'll show you that later. So this is NetBeans, and I am remotely running the Raspberry Pis through a debugger here just to show what's happening, and this is one way that I trace it through. And on the bottom of this you'll see that some of the commands that have been sent to the Raspberry Pi, that's decoding, and I have it located on the address on a local net of 91, and that's Pi number 1. Pi number 2 is 92, Pi number 3 is 93. It was just easy for me to handle this.
Now this is all written in Java, and when a trigger does finally happen, it goes through the system and it will hit this process queue entry up here, and as long as I have pins assigned to the camera, the next thing it's going to do is it's going to fire off a pulse of whatever the duration I set, and I have found that my Canon requires a pulse between 350 milliseconds to 500 milliseconds to trigger out. No big deal. So this one is pretty simple. What I'm showing you on the bottom here is I actually got two triggers going on. So once I pass over my hand through the beam, I've gotten one trigger, and the trigger tells me how far away from the sensor and what the percentage of the total distance was that the sensor triggered on. And for these demos, I also did two callbacks. So I can put one callback, I can put 100 callbacks in for one event. So what that means is that I could, when I pass my hand over a sensor or somebody breaks a sensor, it could, snap the picture, send me an email, put it up on a website, and ring a doorbell somewhere. So I tried to make it as versatile, and probably a lot of overkill on this one, but it was fun. So here I'm showing a couple of different breaks of the beam and how that looks on the unit. This is the simple script that I use to start off the rangefinder. I just send it to the Raspberry Pis. That second line pointed to by the blue simply says, okay, I want to take samples from the rangefinder at a rate of 4 per second. I can set it up for 4 per minute, I can set it up for 100 per second, I can set it up for 100 per hour. I have it set up all the way up to a full day, so you can do that very easily. The next entry says, okay, for a trigger on the rangefinder, 30% and trigger on high to low. So that way I only get one trigger through. If I said low to high, then when the beam was unbroken again, it would fire off. High to low will fire off when the beam is initially broken. And then I can also have it set up so that it will break and issue a trigger on when the beam is broken and when the beam is restored. The next two entries basically will tell us that how to issue a callback. So I had two callbacks for the rangefinder. Both of them were added. The first one is test number 2, which does really nothing much other than just, push it out there that says, into the log log file that says, yeah, okay, it broke. But the second one is a little bit more interesting because that's the one that actually does the camera. So that one says basically, okay, add a callback to the rangefinder, call it test number 3, give it a test of my camera event callback. The callback is going to use pin number 37 of the Pi server, and it's going to fire it off for 400s, and the unit is going to be in milliseconds. So summarizing, the light is broken, the laser breaks the light, causes this to trigger, which fires off pin 37 on my Raspberry Pi for 400 milliseconds, and that should then fire off the camera. The transistor, which goes to ground, and voila, I get my camera focus or my camera snap and shutter signals that I need. Took me probably about 15 minutes to build this thing, and it works like a champ. So, in a summary, this is pretty simple, and with all the different other sensors I can put on the system, it makes it really easy to add other functions. So I don't have to limit myself to just those sensors. I can have a signal come in off the bus to fire off the camera. I can have one come in off the web to go into the system to fire off the camera. I could have an automatic timer that says every 15 seconds or 15 minutes or once an hour, fire off the camera. I can have another switch somewhere on a door that says if you open up the door, delay 15 minutes or delay 2 seconds and fire off the camera. It was a really fun project, and I hope you enjoyed it. And if you have any questions, hey, send me a note. Okay, thank you.